The brilliant mind of the weekend is Regiomontanus, the influential German mathematician and astronomer. Johannes Müller von Königsberg, born in 1436 and passed away in 1476, is better known by his Latin name, Regiomontanus. He was one of the most important European mathematicians and astronomers of the 15th century. His life and work bridged the medieval and Renaissance periods. Early life and education. Born in Königsberg, Bavaria, which is now Kaliningrad, in 1436, Regiomontanus showed extraordinary mathematical ability at a young age. He began his studies at the University of Leipzig at the age of 11. Later, he studied at the University of Vienna under Georg von Feuerbach, becoming his most important student. Major mathematical works. De Triangulis Omnimodis, or On Triangles of All Kinds, was written around 1464, but published posthumously in 1533. It was the first European work to treat trigonometry as a distinct mathematical discipline. The book systematically presented both plane and spherical trigonometry. It included the law of sines for plane triangles and detailed trigonometric tables. Epitome of the Almagest was started by his teacher Feuerbach and completed by Regiomontanus. It is a comprehensive summary and commentary on Ptolemy's work. This work made Ptolemy's astronomical concepts more accessible to Renaissance scholars. Tabulae Directionum, or tables of directions, contains detailed trigonometric tables. It included the tangent function, which was revolutionary for its time. Major contributions include trigonometry, where he systematized trigonometric knowledge, developed more accurate trigonometric tables, and introduced the use of tangent in European mathematics. In astronomy, he created more accurate astronomical tables, established a scientific printing press in Nuremberg, and published astronomical almanacs and ephemerides. In mathematical methods, he improved algebraic notation, advanced solution methods for equations, and developed new computational techniques. His work was crucial for the development of navigation. He influenced later astronomers, including Copernicus. His trigonometric methods were essential for the scientific revolution. Let me expand on Regiomontanus's work in trigonometric tables and related publications. Regiomontanus's major works on trigonometric tables appeared in several key publications. Tabulae Directionum et Perfectionum, Tables of Directions, was written around 1467 and published posthumously in 1490. It contained extensive tangent tables calculated for each degree and included tables of sines calculated for every minute of arc. The tables were calculated to 7 decimal places and introduced the first European table of tangents, using a radius of 100,000 units to improve accuracy. De Triangulis, On Triangles, while primarily a theoretical work, contained essential tables. It included sine tables calculated at intervals of 1 degree and used a radius of 60,000 units following Ptolemy's tradition. It also provided methods for calculating new values not in the tables. Tabulae Primimobilis, Tables of the Prime Movable, was another major collection of trigonometric tables published in 1475. It focused on astronomical applications and included extensive sine tables. Key innovations in his tables included accuracy improvements, such as using a larger radius of 100,000 units than previous tables, developing new computational methods to reduce errors, implementing systematic error-checking procedures, and using decimal fractions more extensively than his predecessors. In terms of calculation methods, he developed new interpolation techniques, created methods for verifying calculations, used iterative procedures to improve accuracy, and introduced more systematic approaches to table construction. His organization and presentation of values were more logical, with a clearer presentation format and better explanations of how to use the tables, including work examples. The impact of his tables was vast. They had practical applications in astronomy, navigation, surveying, and architectural calculations. Long-term, his tables remained standard references for over a century, serving as models for later mathematicians and influencing the development of logarithmic tables. They set standards for mathematical table publication. Regiomontanus's work on trigonometric tables represented a significant advance over previous efforts. Earlier tables, such as those by Albertani and other Arabic mathematicians, were less extensive and often less accurate. The increased accuracy and better organization of Regiomontanus's tables made them particularly valuable for practical applications, especially in astronomy and navigation. His work was particularly significant, not just because of the tables themselves, but also because of the systematic methods he developed for creating and verifying them. These methods influenced mathematical practice well beyond trigonometry, contributing to the development of more rigorous mathematical procedures in general. His tables were used well into the 16th century and were essential for the development of astronomy and navigation during the Age of Exploration. They were crucial for later astronomers, including Copernicus, who used accurate trigonometric tables to calculate. The accuracy and comprehensiveness of his tables weren't surpassed until Napier and others developed logarithms in the early 17th century, demonstrating the lasting impact of his work. Regiomontanus died suddenly in Rome in 1476, possibly due to plague or poisoning, while working on calendar reform for Pope Sixtus IV. He was just 40 years old. His contributions to mathematics, particularly in trigonometry, remained influential for centuries. His combination of theoretical knowledge with practical applications helped bridge medieval and Renaissance mathematics. His printing press in Nuremberg became a model for scientific publishing, demonstrating the importance of disseminating mathematical and astronomical knowledge. The thoroughness of his mathematical works, especially De Triangulis Omnimodis, set new standards for mathematical writing and helped establish mathematics as a rigorous discipline independent of its applications to astronomy and other fields. If you like the video, consider subscribing to the channel. Thank you for watching.